Next slide. So we will begin with the round of introductions. Next slide. So I'll first introduce the organizers of this workshop. Firstly, myself. I'm Pratiti Sarkar. I'm a PhD student from IDC School of Design, IIT Bombay, and we are hosting. I'm hosting this workshop along with Amarnath Murugan, who is the research associate in our lab at IDC School of Design, and along with Professor Jayesh Pillai, who is assistant professor at IDC School of Design. First, introduce the organizers of this workshop. Firstly, myself. I'm Pratiti Sarkar. I'm PhD. Before we move on to the further steps of this workshop, we will quickly show what our lab has been doing. With Amarnath Murugan, who is the research associate at IDC School of Design, and along with Professor Jayesh Pillai, who is assistant professor at IDC School of Design. First, introduce the organizers of this workshop. Firstly, myself. I'm Pratiti Sarkar. I'm PhD. Before we move on to the further steps of this workshop, we will quickly show what our lab has been doing. With Amarnath Murugan, who is the research associate at IDC School of Design, and along with Professor Jayesh Pillai, who is assistant professor at IDC School of Design. First, introduce the organizers of this workshop. Firstly, myself. I'm Pratiti Sarkar. I'm PhD. Before we move on to the further steps of this workshop, we will quickly show what our lab has been doing. With Amarnath Murugan, who is the research associate at IDC School of Design, and along with Professor Jayesh Pillai, who is assistant professor at IDC School of Design. First, introduce the organizers of this workshop. Firstly, myself. I'm Pratiti Sarkar. I'm PhD. Before we move on to the further instructions, this workshop, we will quickly show what our lab has along with Amarnath Murugan, who is the research associate at IDC School of Design, and along with Professor Jayesh Pillai, who is assistant professor at IDC School of Design. First, introduce the organizers of this workshop. Firstly, myself. I'm Pratiti Sarkar. I'm PhD. Before we okay, so further instructions. Next slide. Show what our lab has no, along with Amarnath. Let us know what is your experience with AI, who is the research associate to participate in this workshop. What are your thoughts, perceptions, and vision about augmented reality, especially in the context of classrooms? Right. So now the room is open for the audience to speak. Please volunteer to introduce yourselves.
Yeah, I think Manshul is volunteering. Can you start?
Yeah. Hi
Yeah,
everyone.
great.
I'm Anshul Dilani. I'm a third year PhD student at Indraprastha Institute of Information Technology, Delhi, and I am doing my PhD from the Human Centered Design Department under Dr. Aman Karnani. So my area of interest is basically understanding and leveraging virtual reality and augmented reality for vocational training in India. And as I was discussing with Amarnath also, that I started my work with exploring virtual reality for vocational skill training with an understanding that vocational reality provides you much more options of hands-on skill training and vocational training, and it's a very hands-on kind of skilling process. But while doing my formative research, I understood that there are also a lot of limitations which are associated with virtual reality. Like things like it is headset dependent technology, and you need to have these resources available to get people to use that kind of a medium for training. And yes, I feel augmented reality is one of the most futuristic but very near futuristic mediums that can actually augment our classrooms. One, because they are really scalable because of the mobile augmented reality having so many technological advancements. And secondly, I feel that makes your education interactive as well as engaging for students, which I think is in a lot of buzz these days. So I think if we actually leverage AR in the very right way, it can make classroom education really, really, really forward. Thank you.
Thank you, Manshul.
Thanks.
Who
Yeah, that
would
was
like to
great.
go next? Yeah.
I could go.
Yeah, sure.
My name is Khalid Siyam. I'm doing my pre-masters in the German University in Cairo in Egypt, and I got to know more about AR when I was doing my bachelor project in TUM in Munich, Technical University of Munich. This started with like doing my bachelor in augmented reality, and this made me interested in participating in this workshop with my supervisor like gave me ideas about this workshop. And I feel that augmented reality in classrooms is the future because it makes teaching much interesting than the normal ways that are available without augmented reality and without the use of the new technologies.
It was great. Nice to meet you. Yeah.
Thank you.
Who's next? Any volunteers? Any volunteers?
Feel free to interact as the entire session will be interactive. So please
Yeah.
don't be
I
hesitant.
can go.
Yeah, sure.
Hi everyone, it's a pleasure to meet you. I'm Rojin Kamal Muhammad Amin, head of the Digital Cultural Heritage Research Group at Sulaimani Polytechnic University in Kurdistan region of Iraq. I got interested in AR since my master's and PhD at University of Calgary in Canada, where I was using it for cultural heritage purposes. Since then, I have had several collaboration projects on AR in the field of cultural heritage sector, and now we are continuing it through my research group, where we do use explore AR for museums and storytelling in museums and other cultural heritage purposes. What made me interested in this shop is the interactive nature that I read about in the description, and I'm hoping to to interact, especially the part that involves with brainstorming about AR in learning. Through AR in cultural heritage, I got to learn a little bit more about AR and learning in informals, because when you talk about AR and storytelling in museum, it also involves learning, but informal learning. But I am more interested through your workshop to learn more about the formal learning side of AR, as well as interact with the ideation and brainstorming part of it. And when it comes to my thoughts on perception and vision and AR in classroom, I personally, from what I have been doing in the evaluations in my own research, AR is showing promising especially in more effective side of learning, deeper level of learning. But of course, it depends on different level of learning, depending on whether you are augmenting vision or audio or any other senses. Thank you very much.
Thank you.
Thank you so much. It's good to have you here. Who would like to introduce next?
I can go.
Yeah, sure.
Hello, my name is Marina Citeta. I'm from Romania. I work at the University of Bucharest as an associate professor. I have some experience with AR, as I worked for 4 years in projects involving AR for remote collaboration and also an application in healthcare to assess the motor dysfunctions problems of patients in an objective way. This workshop is very interesting for me because I'm very keen to hear about applications of AR in education, and also I would like to have feedback from you regarding our work, our proposal for using AR in education. I'm especially interested in establishing remote collaboration using AR between teachers and pupils. That's a few words about me. Thank you.
That's great. Thank you very much. Yeah, we look forward to discussing more about remote collaboration. So, yeah, thank you. Who wants to go next?
Maybe I can go next. My name is Dragos Dapte. I'm the second author for the paper written together with Marina Cidota, the former speaker. And a few things about me. I work in the Netherlands. My background is in research, academia, doing research on exploring on the augmented reality for building situational awareness. I did projects in safety, security, defense, space. Now I work for Prime Vision. This is a company, a private company in the Netherlands. And today we are presenting something about remote assistance for using augmented reality, which is a very useful tool for the early school dropout prevention. My background is in computer vision and augmented reality. That would be it. Thanks.
Thank you. Great. So, is that everyone, or
I think we also have David here. Amana.
yeah?
I can speak.
Oh yeah, please go ahead.
Sure.
Yeah.
Let me know when you're ready.
Oh, you can start.
Okay, thank you. Can you hear me okay?
Yes.
Right. So I'm a PhD student at the University of South Australia. My name is Bradley Herbert, and my supervisor is Mark Billinghurst. And I'm particularly, my experience of augmented reality has been mixed. So basically what I mean by that is when I first used it, I was quite excited because it was a very novel technology. Then after I'd been using it for a while, that novelty sort of started to fade. And so got me thinking that if people start using AR, they initially find it exciting, but they may or may not become less excited as they continue to use it. Basically, in my research, I'm sort of looking at, can we reduce the amount of AR instruction that we provide as they get more experienced with using it? And so that's basically the perceptions, is that they might think, even though they might think, for example, that AR is helpful, but then as they start using it and you start learning, then the AR content can sort of become redundant. But the learner may not be aware of that, how it's impeding their learning. So they might, so the perceptions can be positive, but there can be, nevertheless, there can be a sort of interference in their learning. So I'm looking at fading out or reducing the AR as they get more experienced and skilled at whatever they're learning. And so that's why I'm interested in this workshop, is understanding the perceptions of AR and how it can be integrated into mobile technology for education.
Oh, that's amazing. So yeah, this has been something that I've been looking into as well. So there's always this issue of novelty getting in the way of evaluating AR because it always tends to give positive results. So yeah, I look forward to the results of your work, and yeah, we look forward to having the workshop. So thank you.
Yeah.
David, would you like to go next?
Yes, hello. All problems, but yeah, as my name is David. I'm from the Technical University of Munich. I'm a PhD student, and my research interests are serious AR and also in context of serious games with AR. And yeah, I'm looking forward to the discussions here and also to the presentations of.
Hello. I think we lost you there for a bit. Can you hear us?
There is
David,
some
can
audio problem, then probably we can move on to the next participant and come back to David later.
yeah.
Yeah, Christian is there. Christian, can you introduce yourself?
Yep, I can do that.
Hi.
My name is Christian Eichen. I'm also from the university, the Technical University of Munich, and I'm also part of the paper of David. Yeah, and we like to work on serious games and gamification using augmented reality to teach people something, maybe about history or about languages, all kinds of different things. So I'm really happy to join the workshop. Thank you.
Thank you. Is there anyone who is left, who is yet to give the introduction?
I think we can continue from the paper presenters.
Oh.
I think everybody has introduced.
Right. So yeah, we will move on then.
All right. Yeah.
Amanat, can you share the screen, please?
PPT is up. Can you? Is it visible? Is it visible?
Yep.
All right.
Yeah, so moving on to the details about this workshop. So this workshop was basically targeted towards bringing together the potential participants who can address the design challenges and considerations in a way that could bring harmony in the teaching learning practice. And these all can be attained through well-defined AR design elements, interactions, and learning activities. So the entire goal of the workshop is to come together to probe into the evolving affordances, challenges, and requirements for AR in the context of classrooms, and to analyze the suitable design elements and interactions that are required for the key stakeholders, and to identify the different ways and techniques that can be used to design the learning environment for the targeted skills of the students. So, as I mentioned before, this entire session is going to be interactive. So, please be ready to have a good amount of discussion going throughout. In this workshop, we are not really going to teach or train you about AR or the implementation of AR. It's just going to be more of a brainstorming session. So, the major goal of this workshop is to provide a unique opportunity to all of you who have come up on this platform and from different communities, and you have come together so we can all collaborate in the different designerly ways to create augmented reality learning experience for classrooms. So we will quickly go through why augmented reality is established in education, and this is especially for those who are watching it on like watching it while it is getting streamed. So we will quickly go through this. So augmented reality is one of the emerging technologies that is being widely used in different domains in various parts of the world. And AR evolved from the concept of virtual reality, which was explored around in 1960s, and this term then came in 1992 when virtual graphics were developed to help aircraft workers in their assembly work. So, in this spectrum, in the concept of Milgram reality virtuality continuum was introduced. And as can be seen in the figure, the left side of the range belonged to the real environment, and the right side of the range belonged to the virtual environment. And blending the two together is what is called mixed reality. And AR gets into the phase where it is the combination of virtual information in a minor amount with the real world. And there are different types of displays. The most popular one is head mounted displays, in which the displays require the users to wear the display device on their head, where the images are projected onto a small display in front of the eyes. Then we have handheld displays, where these displays involve the use of mobile devices like tablets and smartphones, where the camera of the device first scans the environment to map the spatial information and then tracks back in the real time to superimpose the related virtual data onto the real surrounding. Another type of display is that of spatial see-through displays, where these displays involve the video-based display of the real-time event from the screen of the monitor onto a surface. Uh, so if you see on this given diagram, the range depends from the distance from the retinal display. So as it goes further, the spatial existence evolves. And then there are different types of AI implementations. One of these is marker based, which scans the marker through the device's camera and reflect the matched content from the database onto the real world. We then have markerless AR, which again uses the AR implementations which get triggered by scanning the surrounding environment without using any fiducial markers. Third type of AR implementation involves location-based AR, in which the device's GPS and compass and internet connection and image recognition techniques are used to track the features that are defined prior to superimposing the virtual graphics onto the real world. We also have projection based augmented reality, which is also known as video mapping or spatial augmented reality, which involves the projection technique to turn objects that are often irregularly shaped into a display surface for video projection. And this technique has been popularly explored by artists and advertisers who can add extra dimensions, optical illusions, and notions of movement onto previously static objects. Moving on to the existence of augmented reality in learning. So, various approaches have been explored to see the effect of augmented reality in the learning process. So, we have sketchbooks where people do the sketchings. We have seen the use cases in biology where the different organs of the body are being shown and being explored in to help this audience visualize how the things are working in the body parts, which is quite difficult to understand from the 2D diagrams that are there. Then in chemistry, the chemical bonds are something that are being explained and that help in visualizing using AR. Then we have the exploration of augmented reality in geometry, where the different cross sections or certain topics which involve the visualization skills are being explored using AR. Then in engineering aspects also, a lot of concepts are being taught and explored using AR. So overall, AR have
Sorry.
so overall, the advantages of AR have been reported to increase the content understanding, increase the intrinsic motivation and the collaboration in groups, which then leads to the design opportunities of having an integrated classroom environment where augmented reality helps the students in gaining more knowledge by identifying appropriate topics for AR and interactions with AR content. So the motivation of this workshop lied majorly in the emergence of AR in education and how the learning experience can be made immersive and interactive. So we had begun with the Indian context and where different diverse set of learners are there, and we began by understanding the design approaches that can be absorbed and can be taken forward to design such augmented reality learning experiences. And then we are looking into what future directions can be obtained in such a field and what can be the research scope. So, briefly looking into the work that we have done, we had explored the use of augmented reality in two topics of mathematics for middle grade students. One was that of visualizing solid shapes, where the interaction of tap and view has been explored, and the other is that of lines and angles, where the interaction of draw and annotation has been explored. So this was the experimental setup for the visualization of solid shapes. So we had given the designed augmented reality application to the students, and they had got to explore this in groups of four. Then we also did the experimental study with dyads and individuals to understand how they do work in a collaborative environment or in an individual environment. And in this, the topic of lines and angles was given to the students, where they could find and mark the angles that was projected in the that was superimposed in the real environment, and the object that was given to them was that of a house. And this was another setup which was in a rural space, and there also we saw interesting interactions and interactivity among the students. So moving on, we would now like the participants to present their work. So I would now like to call the authors Marina and Dragos to present their work on remote assistance system in augmented reality for early school dropout prevention. So do we have the authors here?
Can you please tell me how I can share the screen with you?
Yeah. Do we have a student volunteer here?
I do not have the bar on the right side on the screen, as I saw it on the training session.
Okay.
We have a
Larina is
student
here.
volunteer. Yes.
Yeah. Larina, can you hear us?
Yes, I can hear you.
Oh yeah. So we need help setting up the another presentation. So,
So should I send you our presentation?
yeah. So you could maybe send it in the private chat here.
Okay.
Is it a Google slide?
Yes, it's a PDF.
Oh, PDF. Okay. Oh, all right.
I uploaded it in the chat.
setting.
Till then, I will also request the other participants to send their presentation so we can upload them as well.
Does this work?
Yeah.
Can I get the PDF?
So, Marina, are you going to present?
Yes.
Yeah. Are you able to see the screen?
Yes, I see the screen, but can I move forward or do you do it?
So, yeah, so you can tell us when you want to go on to
I
the
see
next
an
slide.
arrow.
Yeah, okay.
Yeah, it's perfect.
So if you see, you can see a Zoom's icon on your screen, so you can click that and you can see the entire screen.
Yes, I see it is working.
Yeah, okay.
Please let me know when
Yeah, you can start. Yeah, you can start.
Yeah?
Yeah.
Okay. We have position paper about how to use augmented reality to prevent early school dropout. And we would like to present to you our idea for this problem. We came across to some reports regarding the situation in Romania about early school dropout. The figures that you see here are percentages for young people between 18 and 24 years of age who have graduated at most the 8th grade. So the situation is in Romania is not very good. It ranks the third highest rate in European Union, and the average in EU in 2018 is around 10%, which is quite high. This is a phenomenon that affects the educational systems all over the world. And it's a very serious problem as it results in unemployment, poverty, poor health. In other words, low quality life. The solutions for this problem usually cannot be found in the family of these pupils, as their parents do not exceed their educational performances. So they do not get support from the families to overcome this problem. Also, in rural areas, there is lack of teachers. So there are not enough teachers to teach the pupils in these areas. The human resources, the qualified human resource is scarce. And to use only technology to teach pupils during their primary schools is not a solution. So it's not a solution to let a child alone with a tablet and get good results in education. So in this context, our idea was to use technology, in particular augmented reality, to establish virtual collocation. That means to connect two peoples, a pupil and a teacher that are in different physical locations, so that they can communicate by video and audio tools. Such a tool should be easily deployed at schools or at pupils' home, and it should involve active or retired teachers as well as very good high school students or university students. So this is our idea as part of the solution to prevent early school dropout. When it comes to related work, it has been a great amount of work that regards using technology in education. There are some attempts that use different platforms that do not involve augmented reality. But in this situation, the interaction between the pupil and the teacher is non-existent or is quite limited. When it comes to using augmented reality in education, there is a lot of research at the academic level with different projects that studies the different types of interaction between student and student, student material and student teacher. Also, lately commercial companies are more and more involved in producing educational content. And also, when it comes to using AR for remote assistant, this has been successfully used in industry to provide remote maintenance of industrial machines. When it comes to our experience using augmented reality, Dragos and I have been working for a project with the Dutch police. And the idea here was to provide information on the spot. And that information comes from an expert that is in another physical location. So in the right picture, you can see the expert in front of a laptop. And on the left side, you see 3 pictures with a local policeman who receives indications via the headset. So this is something that we have been working on. We developed the framework and we had different experiments. Now back to our problem, to early school dropout problem. We found a very interesting study performed by Fenn and Walters from 2014 that involved more than 16,000 high school pupils. And one of the findings of this study was that math is a core subject in the educational process, and the pupils' genuine interest in math is indirectly related to his behavior of leaving school earlier. And this indirect connection is done through the pupil's educational expectation. In other words, if a pupil has a genuine interest in math, then his educational expectations are higher. And if a pupil's educational expectations are high, then he is expected not to leave school earlier. So this study was done for high school pupils, students, but we thought that is quite valid. The result is quite valid also for primary pupils. So we focused on a scenario where the pupil has to learn math. Usually when you have to learn math, it is better to write on a paper, to write the proof, or to make some arithmetic operations. Okay. So we were trying to imagine a setup where the child could receive help while solving a math exercise. So the teacher sits in front of a laptop and he's able to interact with the system via the keyboard and the mouse, while the child wears that HMD, optical see-through. I think it would be a better option, like HoloLens 2. It would be an excellent option. So the pupil receives indication and corrections via that HMD. So these are superimposed on the writing on the sheet of paper. So this is the architecture that we are thinking of in this particular scenario where the pupil has to learn math. A few ideas about the system design. We are thinking to build this system based on the Moodle platform, which is an open source educational platform. It is very very active with a very active community. So we would implement some plugins for Moodle that would allow for audio and video communication between the pupil and the teacher. So you can imagine that the child is writing some math formulas as in this picture, and via the webcam that is attached on the HMD, the teacher can see in real time what the pupil is writing, and he can correct it using his keyboard and mouse, and he can provide corrections and further explanations if they are required. So what is drawn here with red is only seen in the headset. It's the virtual content provided by the teacher, and it is overlaid on the handwriting of the pupil. The next steps that we are going to take, first we'll have to have a functional prototype in order to perform some pilot experiments. We are thinking of testing it with at least 10 pupils who have learning difficulties in order to get some data for further improvement of the system. So this is the first step. And once we have that software implementation and the pilot experiment, we would be interested in analyzing different aspects regarding human-computer interaction. And we are thinking of two things right now. First would be the situational awareness. That means to provide the tools that are necessary in order for the users, for the pupil and for the teachers, to be aware of each other's activities while communicating with that system. So the teacher should be able to understand what is the pupil difficulty in solving an exercise, and also the pupil should be able to clearly and easily understood the explanations and corrections from the teacher. So this is something that has to be evaluated. And another thing that we consider now is to see what is the additional cognitive task load for the pupil, especially when he has to deal with such a system. Because while he wears the headset, he has to perform some actions, he has to interact with the system, and we have to see whether the interaction with the system has a negative impact regarding the capacity of solving an exercise, whether that impact affects the pupil negatively. So these are some things that has to be studied when we develop such a system. That is our idea when it comes to provide remote assistance to a child that has learning difficulties. He's in danger of abandoning school earlier, and using augmented reality for that purpose. Thank you.
Thank you. That was great. In fact, we are also working on a social AR-based system for teacher and student interactions. So yeah, but we'll discuss more about that in the later part of the session. But yeah, this is great, and I just have a question. So, as part of your architecture, you have mentioned that the teacher will be using a laptop. why did you decide against using a HMD for the teacher as well? Because I assume that you'd have more embodied interaction between the teacher and the student if they're both virtually present in the same space through HMD display.
So why did we consider for people to wear an OST?
Oh, no. Why a laptop for the teacher instead of HMD for the teacher as well?
Yeah, we thought that it may be. It is easy to annotate a sheet of paper with the handwriting. That's our perception. I don't know if it's correct, but we thought that it is easy to make annotation for the teacher to make annotations using keyboards and the mouse than using some natural user interface with a headset.
Okay, so yeah, the technical difficulty does exist, but I thought if the teacher had HMD as well, then you could have like a embodied avatar of the teacher on the student side, so the interactions could be more natural. But yeah, that makes sense.
Yeah, it is something to think about. Thank you very much.
Of course, yeah. Thank you.
Okay. Thank you.
Any other doubts? Yeah,
I had one more question. So, like you said, that it is easier for the teacher to use the laptop and give the annotations, and the students these annotations on the piece of paper that they are writing. Wouldn't it be an equally similar approach if the student also has the laptop and can directly see the annotations on the laptop screen itself? Like, did you see any additional level of immersiveness being provided by giving the student an HMD and comparing it with if he was given the same annotations on a laptop? Because I think the amount of interactivity between the teacher and student still remains the same.
The sound was not not very clear.
Okay, am I clear, audible now?
Yes, I hear some echo, but can you please say again?
Yeah, can you hear me clearly now? Should I go ahead? Hello? Am I audible?
Manchal, you're audible.
Can I go ahead with my question?
Yes, I'm not sure if Marina is able to hear.
Or what I'll do is I'll put her a question on chat. I think that's more
Yeah.
So you wrote something on the chat?
Yeah, I think she's able to hear.
So can we set up the next session? I think we are lagging a bit in our schedule.
I don't know. I do not see it on the chat. Maybe we can talk later about that.
Yeah, I think that should work. So, I think we can move on. So for the next paper, we can go ahead. Sorry. So the next paper would be presented by Manchal. It's on augmented reality for vocational education. Manchal, I suppose, did you share your PPT with us?
I'm just sharing my screen with you all.
Oh, okay, that's great.
I think that's visible. I'll start.
Yes. Yeah.
So, hi everyone. I'm Manshu Delani, and as I mentioned earlier, I'm a third year PhD student at Indraprastha Institute of Information Technology, working under the guidance of Dr. Aman Parnami. And I am in this workshop. I'm going to present my research, preliminary research on leveraging augmented reality for vocational training education in K-12 classrooms. Uh, So, starting with vocational education training has always played a very important role in any country's economy. So, it basically promotes local manufacturing and helps develop an employable population for any country which there exists. And this not only leads to a self reliant and self sufficient nation, but also a self sustainable population. As soon as they become workable, they become self sustainable to themselves, which in turn leads to a positive economic growth of the country. Countries, especially like India, where the demographic dividend is constantly increasing in the coming few decades, it has become even more essential to tap into this potential of available workforce which is there for economic growth. And therefore, there is this need of promoting vocational education training to skill this workforce. So much so that India, in its latest national education policy, has provisioned for the introduction of vocational education in the K-12 education, and that is where this topic comes to relevance to this workshop. Uh, in fact, if you see globally also, the Sustainable Development Goal 4.3 talks about equal access to affordable technical, vocational, and higher education. So we can see the importance of vocational education being realized in the national as well as global scenario. However, to implement these provisions, it has become crucial to look for scalable and effective ways as pedagogical aids to get them into the existing learning systems. So, if you see till now, mainstream education and vocational education have usually been considered as two parallel tracks of education, where the inability to excel in one, which is mainstream education, is has often led to switching to the vocational education side of the system, and this is especially very prevalent in countries like India, because and all this parallel track and this notion actually leads to a lot of social stigmas to associate with vocational education training, because of which students are demotivated to actually take up these forms of education and go further in them. Therefore, to actually implement the national education policy in its core, to actually get some implementation level, it has become very important to find out creative ways to bridge the gap between these two forms of education and have a cohesive education system where these two are not parallel tracks but actually go hand in hand with one another. This, we believe, will not only help in promoting vocational education training as an equally reputed form of education system, but it will also help in making mainstream education a more interactive and application oriented education system, which I think is now being very extensively proven to be an important form of education. So, hands-on learning and constructionist learning are becoming more and more famous for mainstream education also. And vocational education being very hands-on training actually can add those elements to mainstream education as well. We are therefore proposing augmented reality as a potential medium to teach vocational skills to K-12 students. And why we are proposing this is the affordances of augmented reality that we feel can actually suit very well to vocational education is first, that it can gamify skill training, thereby making students more interested into vocational skill training. And at the same time, we have this notion that it will reduce the stigma which is associated with vocational training education and motivate more and more students to actually pursue these courses as well. Then, augmented reality has this very great potential of resolving the infrastructural dependencies which are associated with vocational education training. So currently in our country, vocational education training happens in dedicated institutes, and I think it happens in most of the countries this way, that these are dedicated training institutes like industrial training institutes where there is infrastructure available for vocational skill training and students go and train there. However, now to bring this vocational education to mainstream schools and within the K-12 paradigm, there'll be a need of a lot of infrastructure that has to be created if you want to start, vocational training of students. However, I think augmented reality provides a midway path where actually you can, use some of the augmentation properties and create a dummy infrastructure where students can actually at least start learning till the actual infrastructure is available for these kind of learnings. Third, we believe that augmented reality with its capabilities of overlaying information into the real world, overlaying virtual components into the real world, has this very interesting opportunity of actually bridging the mainstream education and vocational education both ways. So one, in mainstream education, you can actually, while teaching a student about some concept, you can overlay applications in the form of vocational trades, which can make students better understand that how this mainstream education is going to be relevant in their life, and vice versa. So while learning vocational education skills, the mainstream concepts can be overlaid in those classrooms to make them understand that how equally challenging, or it's not a small form of education, it's an equally challenging form of education where you need the concepts that you have learned in mainstream education as well. Another important feature that augmented reality gives us is that train our workforce for jobs of the future. So in my preliminary research, I came across this fact that vocational training in our country till now also is limited to very traditional trades. So they are limited to things like CNC, lathing, machinery, and all those kind of things. But for the jobs of the future, like jobs in the area of renewable energy, or let's say in the transportation energy, or those kind of things, are still very limited in vocational institutes. So again, augmented reality being having the capability of augmenting your environment in any way you like gives you this opportunity to even train students for jobs which will be more relevant in the upcoming decades and get them ready for the jobs of the future. Finally, augmented reality provides this hands-on approach or constructionist learning approach, which has been proven to be very important and relevant in current pedagogical mechanisms, and can therefore help students get more engaged in their learning. And here we're talking about a mixture of vocational education and mainstream education, and not just doing hands-on things in mainstream education. So you can take hands-on things from vocational education, use augmented reality to put them into mainstream education, and have a very good amalgamated constructionist approach towards both. And finally, we feel that augmented reality can actually help scaffolding, contextual and situated learning concepts to students and make them better understand of what they are trying to learn. So this has been explored a lot in mainstream education, like Pratiti showed, that showing lines and angles, annotating them, and students can draw that. But now we are actually trying to take this to vocational education, where actually the student can understand. So let's say if you're talking about carpentry, a student can understand that, okay, this is where I need to draw lines and angles in carpentry, and if I have to do a skill like that. And we can actually use the capabilities of AR to scaffold this information into their learning systems. And that will, we feel that is a good opportunity that exists in terms of AR. Coming to the related work or the current scenario which exists, augmented reality has been used for skill training, but that has mostly been limited to the medical domain, where things like child delivery, needle emplacement, laparoscopic surgery, ultrasound simulator, etc., have been explored using augmented reality. It has been used to some extent in the military training, where people are taught about law enforcement operations, call for fire procedures, and things like that. And some very preliminary work has been done in the field of vocational training using AR, where people have been taught about things like industrial processes, PCB assembly, and vocational tools in AR. However, as you can see, this has been very limited, considering the vast umbrella of skills that vocational skill training can actually cover. It is mostly very towards the industrial side of things. And we therefore find the following opportunities that augmented reality can have in AR for vocational skill training. So starting with looking into low cost and scalable mobile augmented reality based learning modules for a variety of vocational trades. So right now we are concentrated on the kind of vocational trades that augmented reality has looked into for teaching vocational skills. So there is a huge range of skills that can actually be explored and taught using augmented reality and create modules for them. Coming to the next opportunity, since till now augmented reality in mainstream education has still been a semi-active experience, I think vocational skill training provides the challenge, being very hands-on skills, to have more active and interactive user interfaces and provide students with maximum interactivity in skill training. Third, as Marina also talked about in the last session, was that there is a huge opportunity that exists in creating collaborative augmented learning environments where you can enable communication between different user roles. So we're talking about teachers, parents, as well as students. How can they collaborate in learning, in these learning opportunities, and creating modules which can be used in school as well as at home, just using the infrastructure that is being provided by augmented reality, and not eliminating the dependence on the actual infrastructure that vocational skills training require. Again, since this is a very new area and not a lot of work has been done in augmented reality for vocational skill training, there is this huge scope of actually creating framework and platforms as to how AR can be used for experiential learning and to be integrated in the traditional training methodology that actually happens. And finally, there is this opportunity of authoring AR-based learning content to actually facilitate the teachers or trainers that already exist so that they can create their own learning modules for their students and eliminating the dependency on external software developers. So the current work that we're trying to do is we are taking different case studies of different vocational skills and the theoretical concepts in mainstream education that actually exist or are used in those vocational skills, and trying to create augmented reality modules for them. And then we plan to go into the field and actually test them with students and understand whether this amalgamation, or how can we make this amalgamation a more effective amalgamation. The next step, so we plan to do 3 case studies in this area. The next step would be that based on the insights from these case studies that we have, we plan to develop a framework or understanding as to if people want to create in this area or develop in this area, what guidelines can they actually follow to actually create effective learning mechanisms. And then finally, create a basic prototype of an authoring tool which can enable the trainers themselves for rapid prototyping and developing of such learning modules. Thank you.
Yes, thank you, Manshu. That was great. Yeah, I love the idea of combining both theoretical and vocational knowledge. There is transferring knowledge between both the streams. Can you tell me more about the case studies that have managed to achieve those, or have you found any successful cases of it?
So right now we are actually in the implementation stage of the first case study. So as I said, I started with virtual reality and I've very recently moved into augmented reality. So we are developing this module of carpentry training where, so in carpentry, joints is a very important function that people have to learn, the different kind of joints you make in carpentry. And we are trying to amalgamate some mainstream concepts like angles and lines and mensuration concepts into carpentry and present that to students. So we're still in the implementation stage of the module. We have not yet gone to the field, and seeing the COVID situation, I'm not sure how soon we'll reach there, but that is the first case study that we are still working in.
Oh, great. So yeah, that also kind of aligns with what we have been doing with Scholar in terms of lines and angles. So I look forward to the results of the study.
Yeah, so I was actually looking at that, and that can actually be really helpful for us to create the modules as well.
Of course, yeah. So that is great. Thank you. And if anyone else has doubts, you can shoot. Okay. So in the interest of time, I guess we can move on.
Yeah, I'll just stop sharing my screen. Just
Of course. So we can move on to the next paper, which is called Arsino. Hopefully, I'm pronouncing that right. It's for learning Egyptian hieroglyphs with AR and machine learning. So maybe we can have the authors start the presentation. Khalid?
Yeah, I sent
Amanda,
to the
he has sent you the presentation.
PowerPoint.
Khalid.
Oh, yeah. So is it possible for you to share your screen? I guess that is more responsive than if I set it up.
I will try. So,
Because can the student volunteers help out?
yeah, sure, that would be great.
Yeah. So if you zoom in on the screen by pressing the zoom in button, you should have the bar on your lower right. So I think the third icon from the right should let you share your screen.
On the lower right, it's just you're in a private room, nothing else.
Oh, so it would appear after you zoom in on the screen. So you have to click the magnifier.
I zoomed on the screen, but still.
Oh, you do not see a toolbar at the bottom right?
No.
Matt, I think that maybe only for organizers and student volunteers that this bar is visible. Maybe I was a student volunteer, that is why I was able to share.
Oh, okay.
That
Okay,
may be
then
a possibility, but they can interact with the presentation on the two arrows which are there on the presentation itself. Maybe that is visible to the other participants as well.
Okay. All right. So let me see if I could set it up otherwise. Like. All right, so I'll share my screen and you can let me know when to change the slides. Just a sec.
Oh, okay.
Is this visible? Can you see the PPT?
Yeah, I can see it.
Yes.
Okay, great. So we can start.
Right. Okay. Good afternoon, ladies and gentlemen. I will be presenting the paper with the title Arsenal, which is an application for learning Egyptian hieroglyphs with augmented reality. Next, please. The next slide, please.
Is this slide fine? Or do you want the
No,
next
I want
slide?
the next slide. The next introduction.
Is this it?
Didn't change. Oh yeah. So first I'll be introducing the Egyptian hieroglyphic language. The Egyptian hieroglyphic language is one of the oldest known languages to man, and the language was a dead language between 4 AD till 1799, which means no one could even read or write till the discovery of the Rosetta Stone. After the discovery of the Rosetta Stone, many mysteries about Egyptian culture has been unraveled, and many people became more interested in learning the Egyptian hieroglyphic language, and many universities starting having an Egyptology major. So that motivated us to use the current new technologies, the state-of-the-art technologies, to develop an application that uses augmented reality that helps people with the learning of Egyptian hieroglyphic language. So first, let's talk about the related work to this and existing solutions. For the teaching of hieroglyphs, there is an application called Fabricus, which is done by Ubisoft and Google. This application has its main result is to help scholars in speeding up the work in translation of different hieroglyphs, and it also has a bit interactive part about the learning of the hieroglyphs itself. This also another game called Hero Quest. This is a game that's an interactive game that you unlock puzzles to learn the Egyptian hieroglyphic language. Another source of teaching of Egyptian hieroglyphic language is hieroglyphs step by step, which is the most reliable source since it's done in the Bibliotheca of Alexandria by many experts, but at the same time it lacks the interactivity in the learning part. And for the examples about using the use of deep learning in translation, we have a paper, master's done called Automatic Egyptian Hieroglyphs Recognition, done in 2013. This master's had a name to detect glyphs in a piece of paper, in an image, and translate it to English. Also, the Google Translate application we all know, which has the ability to aim at the text and the translate. Could you please go to the next slide? For the goal of this paper is to get a new approach, which is an interesting, interactive approach for teaching the Egyptian hieroglyphic language, and not only that, but give the approach for teaching other non-Latin languages that are not commonly learned on the internet. So the Egyptian hieroglyphic language was the best example that we used to create, since very low number of universities teach the Egyptian hieroglyphic language, so you don't have the ability to just learn it easily. So our application is a mix between augmented reality, gamification, and the use of machine learning. Please next slide. So the proposal approach is basically that the user writes the Egyptian hieroglyphs on a paper, open the camera gets the image real time, send it to the neural network detects the glyphs in the image, and then the system forms words and sentences from this glyphs and translate them and augment them to the user. Next slide, please. So we could see here a demo. Could you please play the video? It should be a YouTube.
Just a sec. Let's see. Played. Can you send the link in the chat otherwise?
Oh yeah, I could send it. Yeah, 1 second.
It doesn't seem to open. Sorry. Yeah.
Oh, 1 second. I got the link. Could you write it's called this on YouTube if you could, because I couldn't.
Okay.
The link.
Let me see.
May not.
Is it public?
Yeah, it is, but like it's not also showing. So I will send you the. Within getting the link.
Yeah. Oh, I think I got it.
Yeah, that's it. So in the application, as seen, you first get to learn the glyphs. The first thing is you get the glyphs, which are the alphabet of the Egyptian hieroglyphs. You first get information about the glyphs, different glyphs, and their interpretation, and then you're asked to write the glyph and aim the camera at it. After you do that, you get a response from the system, from the application, telling you what the transliteration of this glyphs, which is the English letter representing these glyphs and also the meaning of these glyphs in ancient Egypt. After you finish the glyphs, you go to the words. You also get information about the writing styles of Egyptian hieroglyphs. There are sometimes written from right to left, sometimes from left to right. So you get this information, and then you're also asked to write the word and kind of laggy, and you get that also the translation of this word, and you also get information about what each letter represents in this word. So you also get an image beside it, which makes it better visually learn some of the words by seeing the image besides the words in hieroglyphs. Then they're asked at the end, after all the words, you're given the English words and asked to aim at the corresponding hieroglyphic representation that you already wrote, which revises all the words you already wrote. And then there's a free detection mode where you could just go and aim at the words that you already wrote, and you could get its details to revise more. And also it works on sentences, for some sentences from the of the Shipwrecked Sailor, which is an ancient Egyptian story. Could also pause translation to get more details and to make it easier for you to get the details. Then at the end, there's an evaluation where you get the Egyptian hieroglyphic representation of the word, and you choose the English representation and also the transliteration, which is the letters forming the word. You could go back to the presentation, please.
Can you see the presentation?
Yeah. And now for I'm talking a little bit about the implementation first, because we use a neural network, we need a data set. The data set was a mixture between data set, which was done the masters I mentioned in 2013, which had 4,000 glyphs. But after filtration, because we only chose 35 glyph classes to make it the most common used glyphs, because the Egyptian glyph language actually has around 1,000 different class of glyphs. So it's really huge. So only around 6,800 manually labeled glyphs on those 35 different types of glyphs that made a data set of size 10,000 for around the 35 different classes. And then we use this data set to train the neural network. The neural network that we're choosing will be using in mobile AR. So to use it in mobile AR, it has to be fast and it also has to be small. So SSD Mobile Net version 2 was used with the TensorFlow framework, trained by TensorFlow framework. And this was used because it's really fast and really small and has a good accuracy. And also that augmentation was done to vary some colors to give the images some variation. And this was integrated into Android Studio. Could you please show the image next? And this is showing that each glyph has a bounding box around it and a Gardner representation above it. Not sure if it's really showing here, but it has a Gardner representation, which is the representation for each glyph, the most used Egyptian glyph representation. But the accuracy isn't 100%. Some glyphs are some glyphs are not even shown. Don't have a bounding box around them, because as mentioned, it's a fast neural network. It has to work with real time. So that's why some problems happen, but this will be solved and will be shown in the next slides. The main thing here was to do a dictionary that goes from the Goni representation to the Egyptian. Next slide, please. Yeah, for the implementation, first we form the sentences and the words. This is done by just the sentences are the same horizontal glyphs, so the same horizontal line, and words that glyphs that have horizontal gaps between them. And the translation happens by mapping the words to the dictionary, the detected glyphs to the dictionary. But it's not done exactly like that, because sometimes, as I mentioned, misdetections could happen. So what is done is we measure the Levenstein distance between the detected sentence the detected string, and the dictionary. This helps us in getting the nearest match to the sentence, not the exact match, because sometimes some frames there can't be an exact match. And some enhancements, we did some enhancements to make it a stable application, to make the detection stable, which is that when the detection occurs, it doesn't augment for the user real time. It waits for 25 frames, for 25 detection frames. It detects the sentence 25 times, get all the guesses from the neural network, and then show the most guessed word or sentence, which makes it more stable for the user. And if one frame dropped, it won't be a problem in the application and the stability of the application. Could you please next slide? And as seen, the learning part is first the teaching of the glyphs, which is the alphabet of the language, since it's the most important, the building block of the language. And then after you're taught the glyphs, the words are taught. And then the free detection mode that you could use to rehearse, and the evaluation at the end that you could see how good you learned from this application. Next, please. This application could be enhanced by first enhancing the detection by increasing the dataset, or using other neural network like YOLO or SSD or LSTM object detection, which may yield better results. Or also the application could be added more non-Latin languages could be added to try this approach out with other languages, and to add more 3D objects and to make it unlock the objects while learning. And the evaluation at the end could be used to compare this approach of learning with other, to do some case studies to compare it with other types of learning. Next, please. Conclude, this paper provided an approach, a new approach for learning, which is interactive, which is a bit similar, closer to the university style of learning, where you could write and check whether you have written correct or not. And it provides also a labeled data set and an algorithm to detect the detection of word sentences. Thank you so much.
Yeah, thank you. That was great. So also, I love saying that the neural network was able to detect even handwritten hieroglyphs. So the accuracy was pretty nice. So I was wondering, what are the gamified elements do you plan to integrate with this?
The what?
So what sort of gamified elements do you plan to integrate with this application?
To plan to integrate is more of a score that you could get, like when writing correctly, and the evaluation at the end could be used like more of a test, and then you could unlock more like a 3D, because in the Egyptian culture there's a lot of 3D objects that are interesting, like to the temples and stuff, so you could unlock that kind of ancient Egyptian that motivates more like the learning process.
Interesting. Yeah, sounds amazing. I look forward to the finished application. So
thank you.
So I guess we can move on to our session. So I think all the authors have presented the papers. So maybe we could start out with the activity. Just give me a sec to open our presentation. Okay, so we could start out with our first activity. So the way we have planned this is to give you like a more open-ended problem and let you guys decide what sort of problems you'd like to tackle with regards to AR and classroom sessions. So the brief is kind of broad: design and mobile AR solution for physical or virtual or a hybrid classroom. So because we kind of noticed that even in earlier literature, AR is So there's not a lot of explorations where people looked into how exactly AR fits into a classroom and what sort of interactions it could lead between the different stakeholders and how to make it like an effective solution. So that is still in its preliminary stage.
Amarnath, just
Yes, sir.
sorry for interrupting. I thought it was not updated for everybody, so I was not able to see. Right now, I can see the activity. I hope everybody is able to see the activity brief.
Okay. So is anyone not able to read the activity brief? All right. So I'll move on, but please interrupt me if the PPT is not updated in your side. All right. Okay. So for the first activity, since we have kept it kind of broad, we are leaving it up to the teams to decide which exact problem area they'd like to focus on. So one of the deliverables for this activity would be to give us a defined focus brief of what you're planning to work on. So the next deliverable would be to see the key problems your design is going to solve. So that is again dependent on your focus brief. You could also choose your target audience. So in the case of our project Scholar, we had been focusing on middle school children because that's the age in which they have like more spatial subjects such as lines and angles. So you could decide depending on whichever problem statement you have decided upon. And we'd also like you to clearly mention what is the responsibility of each person who is going to interact with this system is going to be it the teacher, the student, or anyone else in the school management or the parent. So also specifically for the target audience and stakeholder responsibilities, it'd be great if you could give us personas and scenarios. For those who are not familiar with the concepts, persona is usually a hypothetical character who resembles a typical user for a system. So I'd like to clarify that this is not going to be your average user. So it's going to be your typical, someone who's very likely to use such a system. And so what would be their background and what would be their interest? So it's a hypothetical personality. And scenarios is going to be how each person who's going to interact with the system is going to actually interact with them. It's like kind of a story which says what is the life cycle and how each person is involved in it. So yeah, and also since you'd be designing specific activities for whatever subject you're going to choose, we'd also like to know what is your thinking process for designing the activities. So again, this is a collaborative and hands-on session, so you do not worry about your designs being the best. So it's more like we learn from each other. So do not hesitate to put out your ideas. So we were planning to use Miro as a platform to brainstorm and present our ideas. So we have created separate links for each team. I'll announce the teams and send out the link in the private chat so you guys could get started. And before that, is there anyone who's not familiar with Miro? So just in case Professor Jayesh would present a small intro to Miro so that we are aware of the basic features. Then we could split up into teams and maybe start our work. So Jayesh, sir,
I had one doubt. I'm sorry.
Yeah.
Yes, go ahead.
Yeah, so I understand that we can work together in Miro, but how are we going to interact with the team members? Like, what platforms will we be using? Because if we do it here, it will be a lot of noise for everybody.
So I think that's why we have the private space. So we have one outside the room.
Okay.
So and one here. So I thought that would be the split up.
Yeah.
But in case that doesn't work, maybe we could consider other options. So we'll try this out for starters.
Yeah. So before we start, I thought I should also mention that from the participants who are here, there are 6 participants here from the paper presenters. So we have thought about at least having 2 groups so that one group can sit in this space and another group can sit just outside where you can see another private space which is marked with blue color around it. So the groups that we have thought right now, I can just quickly announce, and there are also other participants here apart from the paper presenters. So if they would like to join, not a problem, but please let us know. So there is Manshul, there is Dragos. I hope Dragos is here. If you're here, please let me know. Yes. And Khalid. So three of you would be forming the first group. The second group would be Marina, David, and Christian. Yeah. So apart from that, there are also some participants who have joined today. So if you would like to join, please join one of the groups to start the activity. So yeah, just to show you the Miro board, I'm not sure, Amanat, I'm having some trouble here at my side. So if you can, is it possible that you can click on the Miro link? I can just take them through the.
Yeah. Oh, I think someone changed the layout.
Yeah, I think it's two. Yeah, it's back to.
1 second. Oh, okay. I'm unable to open it through here. I'll share my screen instead.
Okay. So for the participants who are new to Miro board, it's basically a place where you can add small post-its and information with text and different shapes, so that you can quickly do brainstorming around common area. You can also work on a different tab, at your end, and you can collaborate. You will see each other working, together. So you can have the brainstorming on one board. Yeah, so this is the Miro board that I hope everybody can see. This is the Miro board that we have added for you. So there is one each for each team, which we will be sending the link that that we have for each team. We'll be sending on the private chat here. As you can see in the board right now, we have few guidelines for you to work, so that it's always handy with you. And as you can see on the screen on the left side, let me just quickly walk there. Yeah, on the left side, there are a few tools. So, for example, the top one is to select. The second one is for templates and so on and so forth. So you can also see a clipboard, a post-it like icon where you can add your post-its. Amarnath, you can, yeah. So, and you can quickly copy and paste them to have a discussion around it. And or you can use basic commands like that you use in other softwares, like you use option to quickly copy each post-it and make multiple copies of it. Similarly, you have other options like if you you can connect different elements to each other. You can also highlight certain parts of your drawing if you require. And there is also something called frame. So Amarnath, if you come to the second last icon there below, the frame. So you can create quick frames which can be used for presenting later. So if you want to present your ideas later, you can create quick frames, and then you can use that to present your ideas. So that's a basic idea about Miro. I think once you start using it, it's pretty easy to understand. So yeah, over to you, Aman.
Yeah. So if you have any doubts regarding using Miro, let us know. But I think it should be fairly intuitive. So I guess we could get started. I will stop sharing my screen. Okay. So maybe the participants could split up into the mentioned teams for now.
So team 1 can take this room, and team 2 can take the room just outside where I'm facing right now.
Yeah. So just to organize, maybe team 1 can come to the table where I'm standing. So the first team would be Akshul, Dragos, and Khalid. So we have Dragos. Right. Khalid is not here. Okay. What about team 2? Is Marina, was your David? Did they step out?
I'm just posting the group members here on the chat.
Yeah.
I think David has gone to the other room because he's in group 2. Manchul is here.
So Marina is standing outside.
So the team members can probably also contact them and bring them here. So Manchul, why don't you take a seat here, and you can probably contact them through the chat.
Yeah, I'll just get them in touch with them.
So
Yes,
also the people who aren't mentioned in the group. So if anybody else is interested in participating, could let us know. So,
yes, I think Bradley from University of South Australia, you were introduced yourself. So if you're interested, please join the team 1 for the activity. That'll be nice. I can see Bradley. Yeah. I thought also Roseanne was there. Roseanne, I think she's probably left. Yeah. So if you're interested, please join the group.
Yeah. So nobody's in team 1 apart from Anshul, I guess. So let's see. Bradley, are you interested in participating in the activity? You hear me? Yeah.
So I'm just trying to figure out, is there a link I'm meant to go to here?
Oh, so yeah, the links haven't been shared before, but maybe you could join Manshul's team. She's over there.
Sorry, I can't hear you clearly.
Oh, can you hear me better now? Any chance? Yeah, is this better?
Slightly better.
Okay. So maybe you could try joining Manshul's team, which is the table to my left. The person sitting over there could join that team. Maybe. Yeah. So wait, maybe you could follow me.
Okay, I'll follow.
Yeah. So you could join this team maybe. Yeah, you guys could get acquainted. Yeah. So I'll sort out the other team meanwhile. Hi, Marina, can you hear me?
Oh, yes, but I don't know where to go.
Oh yeah, so the other team was supposed to set up outside in that space. Let me see if your other team members are there. Oh,
yeah,
so
this is the space.
but I don't think David or Christians are here. Let's see.
Amarnath, this is the private space for the theme too.
Yeah, but I don't think there are the people. Can you hear me? So can you hear me?
Yeah.
So I don't think. Yeah, we don't have enough people. So we could.
Yeah. I think Manshul mentioned that she's messaged Khalid, and somebody else also had joined, right? There?
Yeah. So maybe we could ask
Bradley.
Marina to join them. Yeah.
Yeah, so if the number is less, then Marina could join them directly. I think that would be better.
Yeah.
You
So,
can maybe help her to reach the table.
Yeah. Marina, so we thought we could add you to another team, but looks like the members aren't here. So maybe you could join team 1. So that should give us enough members to get started. So we could maybe. So Marina, you could join this team. So we have Manshul and Bradley. And yeah, I guess you guys could get started. I'll share the Notion link right now in the chat.
The Miro board, right?
Yeah.
Just a question to Manshul, Marina, and Bradley. Were you able to understand the activity 1 brief? If not, you can let us know. So Amarnath will share it once again with you. Otherwise, you can get started. Thank you.
I think it would be nice if you could share the design brief once again. I have the deliverables written down. Just the design brief, if you can put it on the screen once again, maybe.
So should be in your mind.
You can still keep that brief, that page open, so that we can probably keep it open for some time. We can use it. Yeah. And you all can share. There are other 2-3 screens also here. I think you guys would be able to use that probably while working in the Miro board.
This is visible?
I can see the heading written there as activity 1 design brief, but I cannot see the description of the design brief.
Oh, okay. So I think there is a bit of lag.
Oh, okay.
Try again. Is this better?
Yeah.
Also,
so this is
all of
potential participants. This is the screen, right?
Remember
these.
Amarnath, what we see is remember these points screen. The previous screen is what you want to show, right?
Yeah. So I'm seeing the correct screen, right? Let me just try again. Is this visible?
Again, I can still see the topic. Or you can probably just type the design brief in the chat, and we'll take it from there if that's.
Oh no, so it's in the Miro board. All the deliverables and the. So if you just open that link, all of you should be able to see it.
Sure.
Yeah. So that link is in the private chat.
Yeah, I got that.
Great. Oh, Dragos is here. Hi. So do we have the other participants?
No, so he can still join the same team in that case.
Yeah.
You can help.
So Dragos, can you hear me?
Yes.
Oh, great. So right now there is one team here. So we have Manshul, Marina, and Bradley. You could join them maybe. So the activity details and everything is in the Miro board link that has been shared in the private chat. So maybe you could join them here in the table. And yeah, you guys could get started. Let me know if you have any doubts. Yeah.
Bradley, Marina, shall we start?
Oh, yes. I'm looking on the browser at the link that was shared.
Bradley, are you here? Like, can you hear us?
Yes, I can hear you.
I think Bradley is not able to hear us, or maybe he's offline. I don't know.
Yeah, Dragos are able to open the Miro board.
Yes.
Okay, so yeah, maybe you could join Manshul's team and get started. Um,
So I think Marina, Bradley is also here. We can start ahead with the brief. Design a handheld AR solution for a physical, virtual, or a hybrid classroom.
so, hi guys. So, if you kind of feel reluctant working in a large room, there is the space outside where you should have like a private area to discuss. So, in case you're more comfortable there, you could share.
Yeah, we can go there.
Oh yeah. So, follow me. And the screen should be visible to the people on the inside.
Yeah.
Where are the other videos? Yeah. Yeah, you carpet. So that should be like a private area for you.
You can probably share, one of you could share the Miro board there, and probably you can work on your tabs at your end. Hi, Manshul, are you able to access the board?
Yeah, I have presented and I can take care of the board from here.
Okay, thank you. Go ahead.
So I think we can go ahead, start shooting ideas as to, I think the first question is for what we need to have a focused brief as to for what are we creating the handheld solution in a classroom. So what would we like to, let's say, I think we should have a subject that we want to teach using AR. You guys, can you hear me?
Yes, I can hear you, but I'm not sure what I'm supposed to do.
So I think we just have to ideate on creating one AR based solution for maybe in a virtual classroom or hybrid classroom or a physical classroom, and then answer some questions related to that. So I think first, probably we can choose one of the scenarios out of the physical, virtual, or hybrid classroom, and then decide that what exactly do we want to teach the students, and then move forward with the next questions.
Okay. Should we write something or we just talk?
We can talk and or maybe put ideas on the board also, like whatever works for you. So I think we can maybe try for a virtual classroom since this COVID situation has led to a lot of virtual learning, online learning, which is happening for students. So maybe I think that is one interesting aspect to look into. Any of you feel we should look into some other scenario?
I guess maybe assembly or maintenance tasks might be a good choice for augmented reality.
Mm-hmm.
Or a system to augment different parts of a manual, for instance.
So you're talking about an assembly manual itself?
Yeah, to have a manual, a book, and a smartphone to augment some content. For instance, you see a picture in a book, and when the system recognizes that to create some more spectacular content.
You also may want, if you're using handheld AR, you don't want to have something where you have to use two hands to do the task because you need to be able to hold the tablet up to the marker or whatever. So assembly may not be a good idea because if you're doing an assembly, then you can't hold the tablet at the same time.
You're saying that should be a good idea or that shouldn't be? Sorry, I missed that.
Sorry, what was that?
I'm asking, you said assembly should be a good idea or shouldn't be a good idea?
Well, initially, at first I said it was a good idea, but then if it's handheld AR, it may not be. So I sort of changed my mind about it.
Yeah. Or we could try. I don't know, we could think of maybe training students for some communication skills or something like that. Although I'm still figuring out how would augmented reality make that experience a better one. But that is something which is quite often which is being trained to students now. Like it's an important soft skill that people are really concentrating on teaching to students.
Yeah, that could be something that you might want to look at is the communication using AR as a collaboration tool or something.
What I'll do is I'll just start putting our ideas on the board also. Or we could use something like, I don't know if it's for teaching students, but something like for very kindergarten students, storytelling or something like that using augmented reality. Oh, my iLearn is
Augmented or virtual?
Can you hear me?
Yes, yes. You said augmented reality for storytelling, right?
For young kids.
But should be necessary be augmented or virtual?
It can be augmented as well, like the story can play in their real world in front of them also. It can be virtual, of course, they can be a part of the story that way. But if you're talking about, let's say, augmented reality, it can be just like the story starts playing into their real world.
So are you guys comfortable with Notion right now? Or is there any issues?
We are good, Amarnath.
Yeah. So for this session, we have one more hour. And then we have like a 5 hour gap in the middle, and then we start again. So I was wondering how much time you guys would need to sort these out. So either we finish off in 45 minutes and discuss uh, the results, or we could move the discussion to the next slot so that the next 1 hour is just purely for your planning. What do you guys prefer?
I think 45 minutes should also be fine.
Okay. So yeah, anyways, like yeah, take your time. We'll see how things go. So I'll come back. I'll be around
Yeah.
anyway. So, but I'll remind you guys when 45 minutes are up, so we can take a call then. Right.
I think another option could be, say, teaching shapes to students from real world objects. So, like you point your handheld AR device to some real world object, and you actually are shown the shape that it closely relates to.
Sorry, could you repeat that, please?
Sorry? I couldn't hear you, Bradley. Can you just pardon me? Or what else could we teach? Uh, one another idea that comes to my mind is maybe using second or third language learning. So then again, say you point out your augmented reality handheld device to different objects in the world, and you get to know what it is called in another language. Any other skills that are coming to mind, or like should we start brainstorming on each of these and see that which is a good option?
The other thing I was going to mention was if you're using handheld AR, children may not be able to hold it for a long time. There was a study done actually about children's motor skills, and I think it was handheld AR, and there was different usability requirements.
So you're saying that we should target an older age group as compared to like very small kids?
Yeah, well, you have two choices. You could obviously design it for older children, or you can consider you can design it so they don't have to hold it for a long time. For example, you might be able to use a stand to put the tablet on or something, so they're not holding it all the time.
Holding it all the time, yeah.
Pardon?
Yeah, I agree with your point that if we could have something so that they don't have to hold it for long durations would be a better option. I'm not sure if we can tweak the design brief to that extent, or maybe we can because still it's handheld AR, right? If it's a mobile phone which is there on a stand or a tablet which is there on a stand.
You could certainly combine speech recognition as well with augmented reality to teach language learning as well. So then they would learn what commands they have to speak in order to
Interact with the system?
Sorry?
You're saying what commands to speak to interact with the system?
Basically, if children need to learn a new language, then they need to know what the commands are. So the speech recognition allows them to practice the words that they've learned. But it would have to be something related to spatial relations.
Sorry, so I didn't get the part about the spatial relations. Still that I could understand the language acquisition part, but you were saying something about the spatial relations as well. Can you repeat that? So are we going for language learning using handheld AR?
Uh, language learning sounds okay to me.
Yeah, I think I agree with you. I think I'll have to ask Marina also to step inside. I don't think we can hear her. I'll just drop her a message.
Okay.
Oh, yeah, Marina, I think we'll be able to hear you now.
Yeah, yeah.
Yeah. So me and Bradley were thinking that we can go for say like language learning using AR as a medium.
Yes, that sounds very nice. Also, I think it's very suitable for math to display things to show how different formulas are applied in real world, something like that, or to display some graphs for mathematical functions.
Okay, so now I think the next thing we have to decide is about whether we are targeting it for a physical classroom or a virtual classroom or a hybrid classroom. I think we could target this for a virtual classroom. One reason being that currently this pandemic situation has led to a lot of online learning, as I was mentioning before also. Secondly, I feel language acquisition also happens a lot of times with at your home also. Like the first language that we learn is usually what we learn from at home. So I think we could probably have this as a virtual classroom session where so that students can also, go and evaluate outside scenarios and learn what things are called in outside scenarios by pointing out their augmented reality device. And so you go and find a flower in a garden and you want to know what it is known in another language. So something like that. What do you guys feel?
Yeah, that would be nice.
Okay, so I think we are fixed that with the skill that we want to teach and the mode of learning. So we have, I think we have a focused being saying that we want to use handheld AR for language acquisition. in virtual classrooms. For I think we also need to have an age group of students that we particularly want to target at. So like Bradley was suggesting, we maybe should not go for very young students. So Bradley, what do you suggest? What age of students is there when you can actually start giving them these augmented reality things and it will be easy for them to handle?
Maybe for high school students.
Okay. So then we talk about learning foreign languages, right? Because they would already have the first or maybe even a second language acquisition, which is already there.
Right.
Okay. So now coming to the next deliverable, the key problem that our design must solve. So I think the first problem that normal language acquisition usually has is that it's a very passive form of learning. You're just given the words and what are they called in the other languages, and you're asked to maybe learn them. But this AR kind of module can actually make it active by first you can interact with the environment, and then second, like Bradley was suggesting, that we also have a speech recognition module that when you say something out in another language, that can also be evaluated and corrected. Any other key problems that you feel can be solved by using an augmented reality solution?
Maybe to offer some reward when you achieve a level or when you do something good.
Mm-hmm. Also, one question that is coming to my mind is that how would we actually make it a more preferable solution for over something like Duolingo? So, like the language learning apps that we have, what would be additional in our augmented reality module that would, make the solution better than these existing applications? Any other thing that is coming to mind, or should we move to the personas part?
maybe to integrate it with the immediate experience, real experience. For instance, you walk on a street and see a building, and you get some information in that particular language about that building.
Okay.
Or you walk on a sidewalk and I don't know, the smartphone identifies a tree and gives you some information in that language about the tree. Maybe it is easy to remember the words if you learn in a certain context.
Also, I think now since we're talking about a virtual solution, it is more of a anytime, anywhere learning rather than a dedicated time, where you want to learn these things. So whenever you're moving with your phone, say you can get these new things to learn about.
Yes.
Should we move on to the personas part of the activity? I was saying, Bradley, should we move on to the personas part of the activity? Like where we discuss the target audience who are going to be there. So like one is of course high school student. Do we should we have any other stakeholders like teachers or maybe I think we can have another kind of stakeholder. Let's say you are somebody who is proficient in some language and you can actually annotate things in real time. So the app actually learns in real time different languages. So say let's say I'm an Indian and I know Hindi, and while I'm walking on the road I find a tree, I point my phone towards it and annotate it as a paid in Hindi, like what is called in Hindi, and so that the application can learn on itself to actually create new and new uh, more data about languages.
So that's related to content creation, right?
Yeah.
Should also display information about the tree as well, so not just that it's a tree, but also other useful information about the tree that the learner may want to know in their own language. So, for example, they speak Hindi, then display it in that language, the information about the tree.
So something like interesting facts about different things. So it's like an additional learning over the language acquisition part, something like that.
Yeah, that's right. That's what I was thinking. So that they would have to learn what the language is in their, not their own native language, but their secondary language. So if you're a Hindi speaker, then you already know that language, right?
Yeah.
So you probably want to learn English or some other language.
Okay, so we have basically two stakeholders, right? One is high school students who want to learn new languages.
Yeah, high school's probably good because they're fit enough to hold the tablet and they're probably old enough to be able to learn the secondary language.
Yeah. Another stakeholder is maybe content creators who want to get more data into the application.
Yeah, that's right. Researchers could also be stakeholder as well.
So researchers for developing the user experience and all those kind of things.
That's right.
Mm-hmm.
I've just posted a list in the comments.
Yeah. What exactly would be the role of teachers in this application? It's like real-time learning with teachers also, or is just the app teaching? Like you have written one of the stakeholders to be teachers, right?
Sorry, what was that?
I was just asking like how are you envisioning teachers to be a stakeholder for this application?
Oh, you're asking about the researchers?
The teachers.
So the teachers have to basically they have to guide the learner using it. So you still have to teach. So this is an assisting tool, but you still might want a teacher to explain more than what the application provides.
Mm-hmm.
So basically, you're supplementing the AR on its own is very limited in what it can teach. So you want to supplement that instruction with some kind of tutoring. Actually, tutor is probably a good word to use here as well.
Okay. Hey, Amarnath, since you're here, I had this one question that what exactly do we need to think about in the activity design rationale? I mean, aren't the 4 or 5 steps which are above that also a part of the activity design rationale itself?
Kind of. So,
Yes. Anything extra that we need to talk about in the
Hey,
rationale? It's just an overview. Since you're here, I had this one question.
Yeah. So from our approach, we were considering um, the other points would cover stuff that's beyond learning. So it's more about the social aspects of and all that. So an activity design rationale is more about what are the sort of activities that will be present, and if there is any segmentation within that, or if you're following like a specific learning model of sorts. Yeah, like Bloom's taxonomy, or if you take like a part of it. Again, so if you think that the other points cover them, it's all right. From our approach, we were just thinking that sort of segregation.
Oh, okay.
it might vary on the brief that you guys have chosen. Also, there is 5 minutes left on our timing, but do you think it should be fine, or do you want to have the discussion in the next session?
Bradley, Marina, what do you think?
Yeah, we can talk the next
Okay.
session.
Yeah.
Oh, next session. All right. Okay.
Marina, can't we talk in this session itself? Do we have more to discuss?
Now maybe we can come up with more features to this.
Okay.
Okay, so or what we could do is we'll have a discussion in 5 minutes, and you could maybe take in the feedback, and maybe whatever comes out of the group discussion could be incorporated into this, and we can see how we can build it up over an activity too as well. Or yeah, and see how that goes. Does that work?
Yes, that's fine.
Oh, great. All right. So I'll ask the organizers to come to the main room. So once you guys are done, we could assemble in the main hall, and we could start the presentation.
Yeah, sure.
All right. Yeah.
One of the other features also might be there's a paper on teaching English and augmented reality using learning styles. Some people are considered global thinkers, whereas others are considered more procedural focused. So you may want to integrate that into the application as well.
Could you explain this a bit further? I could not really understand this in the context. Could you give an example or something to make it more clear?
Okay, so basically every student has their own personality, so you may want to personalize the instruction based on their personality of some kind. Actually, you could personalize it based on their knowledge too. So if I already know about the tree, then there's no point showing that knowledge to me because I already know it. But you could show knowledge that I don't know, so you could have it personalized to each learner.
Okay.
You could use artificial intelligence to detect differences.
Okay. So maybe something like levels of learners, whether they are beginners or advanced level students and things like that.
Yeah, that's right, because there's a theory in cognitive load theory. If you present information that someone already knows, you can actually degrade their learning.
Oh, yeah. That is one theory probably we can talk about there.
I've put some comments in, I'll put some notes in the comments as well of the private chat.
Okay.
In case you missed what I'm saying.
I was thinking of a feature to correct our pronunciation. When we say something wrong, correct us or say it's not right or give us notification.
So you're saying that the system can give some kind of feedback, or am I misunderstanding?
Yeah.
See.
Marina, could you repeat the feature that you just mentioned?
To check for our pronunciation. I have seen such an app for Dutch language. You are asked to say to pronounce a sentence, and you got feedback whether the system understood it or not.
So I'm trying to understand how augmented reality would fit into this. Are you saying something like when I'm trying to pronounce something, I'm shown a pitch kind of graph which I can follow while saying that word, and that can be augmented onto my screen?
Yeah, well, it's not something necessarily related to augmented, but I think it's a very useful feature when you want to learn a language.
Mm-hmm. So, any other things that we need to discuss, or should we go into the main room and discuss this there?
Just one moment. I don't believe so. Let me check here. Target audience, design rationale. So one thing that might be important to lay out is why do we need to use augmented reality for this purpose? Why can't we just use the existing method of teaching?
Mm-hmm. So, like we were discussing about that hardware, right? Where we thought that it's more kind of an active learning rather than passive learning. You can interact with the real world objects and those kind of things. Wasn't that our rationale of using augmented reality for teaching something like this?
So I think it's about time. Sorry to interrupt. So can we wrap up and move to the other room?
Yeah, we'll just join you.
Yeah, great.
Okay, I think we can head back to the main room now and then what we have, or rather discuss. Running as an AR handheld education support tool for secondary language learning. So the idea is you'll be out in the street somewhere and you'll point, and a high school student will point their tablet at a tree, and it will give that high school student information about the tree in their secondary language. So for example, if they're a Hindi student, then their secondary language may, for example, be the English language. And so it will show the information in that language. But more than that, it will also use some kind of personalized artificial intelligence to adapt what is shown to the learner. So if they already know certain facts about the tree, then it will show different facts that they don't know. So then it's not showing them information that they already know. Because if we show someone information they already know, then what that leads to is what we call a redundancy effect, and that can actually degrade their learning. That's sort of what we came up with in the time that.
So
Yeah,
were
so
you able
if
to
I
discuss each point? Sorry, yeah.
Yeah, so if I could add to what Bradley said, so first of all, we started with understanding as to what do we want to teach to students. Like if you want to have one solution, AR-based, handheld AR-based solution to teach for the students, and we came up with these skills, which probably you can see on our mirror board, like teaching an assembly task or soft skills or communication skills to students, storytelling for kindergarten students, language acquisition, mathematical learning, and all those kinds of things. And we had various reasons that we finally pinned down to the language acquisition part, because so we had some interesting things like storytelling for kindergarten students, but we had a little inhibition about it, since we felt and Bradley pointed out that there have been research studies which say that having such young children to hold them AR devices is not a very good idea. So they get fatigued very easily with such handheld devices. Assembly tasks we could not take up because it's more of a hands-on kind of thing, and having a like both the hands are required, so having maybe a handheld AR would not be such a good idea. So finally we pinned down on this language acquisition approach, and so our focused brief actually is that development of a handheld augmented reality application for foreign language education in virtual classrooms for high school students. So our rationale for going for a virtual classroom was, one, the current focus on online education because of the pandemic which has been there. So more and more things are getting online now. So that's why we wanted to explore that as a scenario. And another reason was that then language learning, as we've always seen, is not just limited to your classroom. So like even the first language that we learn when we are young happens at home and in the world around us. So that's why we went for a virtual kind of classroom thing. Coming to the key problems that the design must solve. So as we see, there are already a lot of language acquisition tools, but now we felt that augmented reality application could be something more like a more interactive and active form of learning. So the basic feature of this app was that you point something into the real world, and you start getting this augmentation of what that thing is called in different languages, and you can learn more like that. We also thought that there could be a feature of something like speech recognition in the application, where we are trying to learn to say something, the speech is recognized, and you get feedback on how well you are saying that in another language. And then, of course, there could be gamification features like rewards and stuff. Another key problem that it would solve is that then the student would actually be learning in context. So, say I'm learning what is a banyan tree or a mango tree called in French, I would actually learn it in context where there is a banyan tree or mango tree around me. And we thought that a more contextual learning may have some positive effects, which of course need to be evaluated. And then last, this would provide an anytime, anywhere learning kind of module where students, anywhere they are walking, playing, they can just take out their phone and start learning about things wherever they want. A few more features we discussed were something like teaching pronunciation within the application itself, because pronunciation is an important part of language acquisition. So while I'm trying to say a word, I get a pitch graph or something like that augmented in my world, which I can follow to say the right pronunciation and things like that. Coming to the target audience, we felt the primary stakeholders for this kind of an application will be high school students who are more interested into foreign language learning, like they have a first and a second, maybe even a second language acquisition, but they want to learn more about some foreign language. Apart from that, another important stakeholder could be content creators. So let's say me being an Indian, I know Hindi, I can probably provide content to the app. So let's say I point to a tree in the environment and annotate it as paid, that it is known as paid in Hindi, and things like that. The second would be content creators, and thirdly, the stakeholders would be the or the participants, like the people associated with the application, would be the app developers, researchers, HCI researchers, who would want to understand the various things from this app. Um, Finally, coming to the activity design rationale, like Bradley correctly mentioned, that one thing that we wanted to be very sure about in our app was that it has some knowledge, some levels of learning, like intermediate, beginners, and advanced levels. because of things like cognitive load theory and all, where the students, if you teach something redundant, you can actually degrade their knowledge. So this is one point that we were still in discussion about, but we were talking about things like these cognitive load theory and those kind of rationales that we were trying to put into the application. Yeah, that's all from my side.
Nice. So is there anything else that the team would like to add on? Okay, so I have a doubt. So when considering stakeholders, did you also think about what role the teacher would play, or is this is this like a app where the teacher's role is required?
No, yeah. So we did talk about that. I'm sorry, I forgot to mention about it. So we were talking about this to be more of a supplementary kind of application, because since we're talking about the content being generated on the go, it may not necessarily have all language learning
What
components
role
from
the
the very
teacher would
beginning
play?
itself. So the teachers, students learn with teachers, of course, which happens, let's say it's happening virtually or in classroom. This is just like a supplementary tool for students to actually, let's say, reinstantiate their learning and revise their learning.
So I was thinking about the prior work done with the other team, the team which worked on Egyptian hieroglyphs. So I thought there were some uh, parallels with the games they have mentioned in their prior research. So it might be interesting to see how this sort of approach, wherein you go out, you point at a tree, could be combined with the approach Pokemon Go took. So that seemed interesting. So also recently, I think there is a Harry Potter game which is kind of built on the same approach to Pokemon Go. And when you mentioned that you can check the pronunciation of the person, I was thinking about it in lines of the spells cast by the person. So
Yeah.
could drive like a narrative or get the person involved in this sort of aspect. So I mean, a lot of potential gamification in this project. So interesting. So, Sir or Pratiti, would you like to add anything?
Yeah, so thanks, Bradley and Manshul and Marina for the initial discussion. And it looks really interesting as a starting point and really nice direction that you've taken. It also reminded me of the Google Translate app, which now incorporates additional augmented layer for translating language directly from a board or an image. Which is in front of your hand, and then you can quickly get information about something that you do not know but in your language. So it's really interesting that you want to take it in slightly bit more ahead, in the sense that you can look at anything and get some information in the language that you prefer to get. So I think as an initial point is really nice. And since we are going to close the first session, I would say it's a nice point to end with. And I'll request Pratiti to probably mention about what do we do when we come back. So over to you. Yeah.
Yeah. So right now, it's you people have ideated at a broader level, and I guess it would be nice to see how deeper discussions can be indulged into creating the whole learning experience. So in the second session, we will like you to continue working on this problem statement, and we can have further discussions on that. Yeah.
Yes. So I think just to mention, when we come back, we will talk a bit more about what is the expectation from the next discussion, how we are continuing. So that it's clear to you what are the guidelines that we can follow, or what are the things that we need to be presenting after the next discussion. Yes. How about the timing, Prakriti? You can probably inform.
Yeah, so there is around 5 hours of gap from the next session. So we will meet around 4. That comes out to be 4 p.m. Recipe time.
Oh yeah, I just want to say something.
Yeah, sure.
Oh yeah.
Yes.
So I don't think I'll be able to make the second session because I think it's the time zone's not going to be suitable for that for me.
Okay.
Yeah.
Fortunately, I think it's like 5:30 in the morning or something,
Okay.
Yes, it's
yeah,
understandable.
it's already 12:30 a.m. here where I am. So
Oh yeah. So it's 12:30. So it's 12:30.
Yes, yes. But Bradley, thank you very much for attending the first session.
Yeah, thanks a lot.
Yes. Thank you. And yeah, we hope to hear from you soon regarding your work and everything. So stay in touch.
So hopefully in the second session we'll have the other presenters joining along with Manchul and Marina. So since you guys already know the timing, so we can meet back at that time. Yes. Yes.
Okay. See you later. Thank you.
Yeah, thank you.
Thank you.
See you.
Yeah.
Bye-bye.
Bye. See you.
Bye.
Bye.
Yeah. Okay. So